Hi guys, welcome to the video for 9.3.3. I'm going to split this up into two different parts. And so we're going to look at multiple slits and diffraction gratings. Then we're going to do a follow-up video just on the calculations. So let's begin. Okay, first off, this goes clockwise. And so this is our single slit diffraction. This is our double slit diffraction here. So those should look very familiar to you, okay? Just a little reminder that the double slit diffraction is modulated within the single slit diffraction. As we get into the triple, oh my god, triple, I'm just gonna do ×3. Triple slit diffraction and quadruple slit diffraction. Notice that we're getting what I like to call mini maximas. So extra maximas get squeezed in to that same amount of space right here. What that really means is this is 1 meter here, this is 1 meter here, this is 1 meter, they're all 1 meter, okay? So what we're doing is that we're squeezing these guys and we're making them thinner and thinner, okay? So these were A, B, and C, and those are the same ABCs down here. A is going to be more thin, okay? And as we get into the 4 slits, it gets even thinner because you can see that there's 2 mini maximas there now. Okay, so for now, I just want you to take a moment, process that information, and make a prediction on what 5 slits might look like. Right, so I hope you paused the video by now, and 5 slits, what I'm really hoping that you've recognized from these last few minutes is that this is going to have 3, whoa, that went way off. Okay, so I'm going to try to draw this in little pieces here. I'm going to draw a really thin line. 1, 2, 3, okay. Another one, okay, 1, 2, 3. Another one, 1, 2, 3, and so on, okay? It's exactly the same on the other side. Now, one other thing that I haven't mentioned, so that's one part of what you need to know. The other thing you need to know is the intensity, which means the height of these peaks actually get progressively higher and higher, okay? So they get longer and longer with more diffraction gratings, okay? So this last one here might be something like, whoa, that's way up there, okay? But it's really thin line, okay? So that should be what it looks like. Okay, that looks really ugly. I'm just going to try to do that one more time, okay? So it's a really long and thin and something like that, okay? Right, so this is a quick little recap in terms of words. As we increase the number of slits, while keeping D, the slit separation, the same, then the intensity value of the double slit maximas increase, but the spacing between the maximas remain constant, okay? So again, that was talking about everything that we had just talked about there. Something we didn't quite hit on was that the slit separation stays the same. And what that's really saying is that if this is a single slit, well, single slit doesn't have a slit separation because there's no other slit to have a distance separated with, okay? It's this particular value of D. In a double slit, that's the value of D. With a triple slit, what it's trying to say is that it's maintaining the same value of D, okay? So this is a value of 2, this is also a value of 2, okay? With 4 slits, it's also exactly the same. That's also 2. The other thing that I didn't mention here is, generally speaking, the value of B, the slit width here, also generally stays similar, or maybe even the same as well, okay? So the size of the width and the separation between each slits generally stays the same. In terms of the formula, we'll cover that a little bit later, okay, but it's just saying everything in the formula is staying constant, okay? We're just adding more slits to it. That doesn't affect this formula here at all. Okay, diffraction grading, so this is the second half of this video. Diffraction grading is very similar, except what we're doing now is we're not talking about the interference pattern so much as we're talking about how the slits are generated. So we're talking about hundreds or 300 lines or 600 lines within a 1 millimeter piece of space. Okay, and there's tiny little holes between that. Okay, so there's going to be 100 lines here, and there's going to be 300 lines here, okay? And then there's going to be 600 lines here. And so what has to happen then is that because there's so many lines being squeezed in, the slit separation and slit width, exactly the things that we talked about up here, these things have to start changing, okay? So unlike before, with diffraction gratings, the slit separation D here will gradually decrease as we increase the number of slits, okay? So even though that they are all the same, the more there is, the smaller the value of D is, okay? So this is 4, this might be 2, and then it gets smaller and smaller, okay? With the more slits that we add. Okay, that's the main difference between diffraction gratings, and that is mostly the end of this video. Last little bit that I want to conclude with, which will lead into the next video, is that as the number of lines increase, the value of D, the slit separation, must decrease. We've just talked about that, okay? So this is just getting into words for you guys in case you want to copy these into your notebooks. There's actually two different relationships. Increasing the number of lines decreases D, but it also increases the angle as well. Okay, so we've seen how the slit separation decreases. We're going to look at how the angle increases in the next video. Thank you guys. We'll see you in part 2.